Simple molecules. Simple molecules are made up from very simple atoms. Here is a hydrogen atom, and the hydrogen atom has just one bond, and when they bond together they make a simple molecule, that of hydrogen. If another simple molecule of hydrogen comes along, there is no bonding, there's no interaction between the two, simply because all the bonds are used up. So this substance doesn't join together well and becomes a gas at fairly low temperature. If we look at oxygen, oxygen has two bonds, and these two bonds make and join together to make a double bond of oxygen. Now this oxygen with only two bonds, all the bonds are used up. So when another oxygen molecule comes along, these two cannot interact. So oxygen is a gas at a fairly low temperature. Nitrogen, this has three bonds, and so with these three bonds we can get a very strong interaction between the nitrogen atoms. So let's just make one of these. Three very strong bonds, and this does not interact with another nitrogen molecule. I got one of my students to make this, and I gave him the Snatoms and said have a go at making a triple bond, and his idea was, well, I've made the triple bond, sir, and here it is. Not quite what I'd actually imagined. The triple bond involves a bond, another bond, another bond between this nitrogen atom and another nitrogen atom. So we've met one bond, we've met two bonds, and we've met three bonds. Can we have four bonds? Well, no, we can't. If we tried to do something like this with a carbon atom, the bonds just are pointing in the wrong direction. I would get three of these bonds in one direction, which would be okay, but the fourth bond would have to go off in a different direction. So you can't get a molecule with four bonds forming a simple molecule. So the simple molecules are made up from atoms that combine together to make strong, very strong bonds within the molecule, but have no bonds left over, nothing left over at all to allow them to interact. There is one exception to this, and this is the molecule of water. A molecule of water is a peculiar shape, and it's a very peculiar shape because really oxygen is sort of related to carbon. Carbon's got four bonds, and if we look at these four bonds you can see that we've got 1, 2, 3, 4, a tetrahedral shape. If we take the nitrogen, then we can do the same. It's got the four bonds, 1, 2, 3, and it hasn't got a bond here. There isn't a fourth. Does occur very occasionally as ammonium, but there isn't a fourth. But what is here? Well, here we've got a set of electrons, and these electrons, because there's nothing to attach them, move slightly closer to the atom, and that has the effect of pushing these bonds very slightly closer together, only a few degrees. With oxygen we've got another two, if you like, pseudo bonds up here, and they push these hydrogen atoms slightly closer together. This does have the effect that we have with water a slight charge on this side. And because we've got a slight charge on this side, we have the opposite charge on that side. And so these atoms, these little molecules, can interact with one another and can form very weak bonds called hydrogen bonds. And these hydrogen bonds allow these molecules to stick together. And because they can stick together, water, instead of being a gas like all the other simple molecules, the water here is a liquid, and this gives rise to all the properties that we're so familiar with for life on Earth.